Hello guys, welcome to another episode of Xah Talk Show. We are going to code Golang. We're gonna code several languages today. Go language and Emacs and Wolfram language. So what we're gonna do is we're gonna create a hash table. We're gonna go through a directory of about 30,000 files. So for each file, create a hash table. The key is gonna be the full file path, file path like that, and the value. We're gonna ignore the value. The value is just gonna be 1. Okay, so we're gonna do this in Golang. But also another important thing is that let me show you. Okay, another important thing is that we want to have a list of directories to skip. So for example, typically you have the Git directory, and in that directory you have like thousands of files. So you want to, given a list of directories, you want to skip them. So anyway, you create a hash table. Then what you do is that you go through each key in the hash table. You check if the key exists. Of course, it does. But we'll do that to test the speed. Okay, so we write that in Golang. Then we write that in Emacs, then we write that in Wolfram language. I hope we can finish this in like 40 minutes or more. If you are watching offline, watch at 1.5 speed because I ramble. If you are watching here, say hi. Hi, I don't know. Fantastic. Okay. Play at 1.5 speed and skip around when you are watching offline. I'm just gonna go easy. Happy July 4th. Today is July 4th. So this is my tea. And red light. Why red light? I highly recommend you go by red light, because red light, they soothes your eye, soothes your brain. So after the sun is set, turn on red light. It's very good for you. Okay, so let's go back. Okay, so let's begin coding. Okay, let's see. I hope we can do this like finish in 30 minutes or so. Okay, so keyboard block, we don't care. So okay, so this is keyboard block, close. Okay, so here is a code. So what we are doing is that I have this code already. This is validate. This code in Go language is validate a website. So my website is about 10,000 HTML files. If you count image files, it's gonna be like 30,000 files or more. Okay, so you go through basically what you want to do is you want to find bad links. For example, a link like that. So let me demonstrate that. Okay, so copy the file path and go to my script. Okay, close that. Okay, so here's the script, and go down, and here you say where do you want the directory to start checking. Okay, so let's put that and remove that. So input directory is gonna be, let's just check files in Golang. So run it. So now done. So done in 0.3 seconds. It's checking this directory, check all HTML and XML files, done in 0.3 seconds. If there's any bad link, it will print it. But so there's no bad link, but let's try to create one. Okay, so what is this today's talk show? Let's say something. Okay, something a file. Some file no exist. Okay, try to open it, it doesn't exist. Okay, showing browser, so there it is. So copy the file path. Now go to the Golang, close that, go to the Golang directory. So paste the Xah Talk Show directory, run it. Okay, so now it says, finish in 1 second, bad links are printed above. So this is a bad link. Now let's color it. color it. So now you can see, oh God. So you can see, you can jump to it, open it, so it shows right there. So that links doesn't exist. So that is the this Golang script. So can if you can go to my website and you can find it. I just updated it. But this script is pretty slow. If I do this on my website, it takes 40 seconds. The first run will take a minute, because the first run, whenever you write a script that is disk heavy, that access reads file, then it'll take a long time, because disk is very slow, even if you have a flash drive. I have a flash drive. But the second time you run it, then everything is in memory, so you can kind of see it. So the second time will be fast. So even if everything is in memory, this script will still take like 30 seconds. I saved 10 seconds. So I was trying to speed it up. So anyway, let's go to what we have to do today. Okay, so let's just that is the reason, why are we creating a hash map? Because I'm trying to speed up, because one of the issue in Golang is that in Golang, let me show you. So there is no function that checks if file exists. You have to write your own. And basically there's no function that checks if a file exists. This function exists in emaclist in Python and in Wolfram language in others, but not in Golang. So, but if you want to check if a file path, the file exists, you have to write a function yourself like this. And basically you just try to get the information from that file, and if that file doesn't exist, you get an error. Then if there's an error, you return it says, so basically there's no way to check file exists. I don't know why. That's technical details for programming file system implementation. I don't know why. So anyway, so I was wondering if this thing, check file exists, is slowing things down, because every HTML page you have 10 or 20, 30 links to other file. For each link, you have to find the full path and check that file exists. So you are coding this like 100,000 times. So I was wondering if it's faster if you just create a hash table of all files in your directory, then just check the hash key exists. So that's my guess. I don't know for sure. So this is one of the possibility this file is slow. So anyway, let's start to write what we have to do. Okay, so let's start a Golang, and basically so let's start a Golang. Go. So what are we doing is we are doing this copy. Any questions, comments, say it. Okay, hello GCS. Okay, so this is okay, so create a hash table. Okay, so let's begin to code it. So we want to create a hash table. I haven't been coding Golang for like several years, so I don't remember. So Golang, but I have a tutorial, so let's see search for it, you'll find it, xahlee.info, Golang tutorial. So so we want to check, go to data structure. So wait, copy it, go to data structure, map. In Golang it's called map, close that. Go to talk show. So link it. Okay, so we're gonna do Golang and we're gonna do Wolfram language later on. Okay, so Wolfram language tutorial, search for it, you'll find it on xahlee.info. And Wolfram language for programmers, there's also a hash table. So close that. So Wolfram language, and we're gonna do emaclist. Okay, so actually why don't we go to the hash table directory. So Golang map. So in Golang, hash table is called map. Now in wait, God, we gotta do this faster. Okay, So now in Wolfram language, it's called association list, data structure association list. Okay, and in Emac Lisp, it's called hash table. Okay, so vector sequences hash table. Okay, so we're gonna write in all these languages. Can I finish it? I hope so. Let's do quickly. Master coding fast. We need to master coding this. Okay, so yeah. So anyway, so okay, go. Yeah, so that's what. Okay, so now Golang here and Go language hash table. Go language. God, why are we? Okay, I need to reorder the links. Okay, that's why I'm a bit fuzzy. Okay, so Golang Map, Emac Lisp, hash table, Wolfram language association. Okay, so now wait. So go to, so how do you do map in Golang? All you have to do is just that. Okay, so create a hash table map of key string and integer. Okay, that's fine. And now we want to traverse a directory. So how do you traverse a directory? I don't remember. So let's see, walk directory. Okay, in Golang, walking directory is fairly complicated. Okay, so you can check out my tutorial, but basically what you need to do is you need to, it's fairly complicated. Okay, so let me just copy the code here. Well, God. Okay, so Golang walk directory. So let's see. So you need, oh God, you need, okay, so package main, then you need to import, all that. Okay, so we are dealing with static languages, which is always a bit tedious. Okay, so this is input directory. Input directory, go through a directory and print a file name extension. Okay, so we don't need this main. Okay, so delete that. So that is the global variable extra. Okay, so this is how you walk a directory. So this is a hash table. Let's comment out yet. Do function. So let's rename it do file. Let's change it to file. Okay, so walk directory, to walk a directory. So here is our main. Okay, so got this. Okay, we need to finish this fast. So you can see here is a main, and this is a function to. So in order to walk a directory, what you need is basically this block, and this is a line. Okay, file path walked. File path is a package you load. Okay, so what's going on? Cancel that. Yeah, file path is a package you load. So you say file path walked, and you give a directory path, and you give a function. Now you have to write this function. Now the complicated part is that this function, this function, okay, do file. This function is takes 3 arguments, and they needs to be this type string info of the type file system dot entry and x and arrow. Okay, so Golang is a compile language, that's why. So you need to declare io/fs file system to get this entry type. So anyway, so if arrow is nil, so let's write this quickly. So okay, so walk and you need this function. This function takes 3 arguments: the file path, the info, the entry info, and arrows. So this walk will pass the argument to this do file function. Okay, So check error. So if there's an error, then just print and exit. Okay. Otherwise, say we are traversing this path, then find out if it's a directory or file. So if it's a directory, just print is the, okay. Otherwise, print the file name extension. Okay, that's how you do it. So can we run it? Yes, I think so. So right now this just traverse a directory. Okay, so now where's the directory? Right now that's JavaScript. Let's just run it. Okay, fantastic. Okay, so for each file you got the path, then this is a directory name, file name, extension, the path, directory name, file. So this is working perfect. Okay, so now, but we don't need to print all that. We need a hash table. So now declare a hash table, file table. Okay, let's name it x file table. Okay, so that's a hash table. Then how do you add hash table? So okay, so let's go to talk show. Today's talk show, Golang. That's, yeah, okay, so hash table is right there. So how do you add a hash table? You just create map with make. So syntax for, syntax for map type, create map literal expression. Okay, so you can create, you can do it with literal expression. Then create map with make. Then okay, so this is how you add an entry. Okay, close that. Go to our code. So this is how you add. So okay, cut that. So for this function, if it's a directory, do we want to add the directory? No. Okay, so if it's a directory, ignore. Otherwise, we want to add it. Okay, so x file table, then use then directory file path. Okay, no, directory name. Okay, so which one is it? Okay, I don't know what is it. Okay, so I think Xah show in desktop doesn't work when there are spaces in a file path. Oh, okay, so you need to if you file a bug report that's about Emacs, then we'll fix it, or contact me in Discord. But let's focus on this right now. So file path, x path, the file name. So okay, so x path. Okay, so so x path is the entry. Okay, so now add the entry to so we don't want this print, cut it, find out it's a directory or file. So if it's a directory, ignore. Now how do you ignore? I forgot how. When you ignore, how do you like, what value do you have to put there? Empty. Just, you can leave it empty. That's right. This is not Emacs Lisp or functional programming. So anyway, so if it's a file, then you add the file path and just value 1. Okay, so comment that out. You don't want that. Okay, so okay, and the directory, we don't care. File name, remove it. That's how you get the name and the extension. Okay, we don't care. Okay, that's right. Undefined X file table. What? Oh, we commented out. That's right. So this the name is not so good. Let's see X table. Okay, let's just say X table. Okay, run it. Okay, you got arrow. Main something. X table path. So why is it's a map string int. It's a what? Go line 32, I guess. So this is creating a problem. Why is that? So wait, is it because of that? Run it. No. Panic assignment to entry in Neo map. Assignment to entry in Neo map. So how do you do a hash table? What? Oh, that's right. Wait, how did I? Oh yeah, we forgot we got it wrong. Okay, so this should be. That's right. Run it. Okay, so this is Easter. Remove it. Remove it. Run it. Fantastic. Now we created hash table. Now how do you print hash table? Let's print hash table. Okay. What is this? Okay, so leave that. Okay, so now print hash table. So now we need to loop through hash table. Okay, so copy that. You know, static languages got this main thing and got this package. You know, those are annoying because you have like so-called boiler templates. So okay, how do you print hash table? Okay, so for key value in hash table X table, then that's how you print it. Okay, so yeah, so we got key and value. Okay, so that's how you print hash table. Run it. Fantastic. Okay, fantastic. So this is all. These are all my JavaScript files. That's right. So basically we done. So there's one more thing. So we need to specify what file path names to skip. Okay, so I already have the code somewhere here, so let's copy it. So let's use this to skip. Okay, so you need that. So if the file name matches one of these, skip it. Okay, yeah. Okay, so how do you do it? You have to write a function. So let me just find it. Okay, kind of, yeah. So you have to write it is string in array. So let's just copy that. Okay, so here is a function string in array, given a string and given array. So if return true if x equals to any of y. Okay, so then it's just the directory name. So you need to, yeah, you need to get the directory. Okay, so let's go to my file string in array. Okay, local string array, where is it used? So you need to get the directory name. That's the space thing. Yeah, okay, so that's how you call it. I haven't coded Golang for like 3 years or something. Okay, so close it. So now let's go to the traverse. So if it's a directory, so if it's a directory, then if the directory name is one of these to skip, then simply return this. Okay, so where is this? Okay, so you need to be careful. So file path, so so where is this? What is this file path? So this file path is from, oh, that's the package name. No, okay, so good. So close that. So this file path is just a package name dot base. So if it's a directory and it's one of these to skip, and just skip it. Okay. Okay, so before we do that, okay, and let's run it. Okay, now check if there is a directory. Yes, because this I is all images. You see, this I is all image. This is image directory for my JavaScript. So when you, and it's actually got, so there's a lot of it went through all the image directories, for example. But now if it's so we can kind of check that. Okay, let's test this. Okay, go to talk show, copy the file path, close it, and now let's test this talk show file path. Okay, now remove that, so run it. Okay, so we see 2,000 lines of 2,000 lines, and this backslash, let's change it to / that, like on the Windows, let's change it to / okay, so how do you change the slash? There is this function. Okay, so let's go. Did we just close it? Yes. Okay, damn. So we want to right now fireworks is going. Happy July 4th. Right now it's 9:30 in California, so fireworks is going. So file path 2/, okay, then clean. Now clean just means remove extra .. remove redundant, clean the file path. But however, the file path is whatever the native file path syntax. For example, on Windows, it's \. So you want to change it to / because that unifies it. The \/ and / is very annoying, because when you run this on Windows, on the Mac, it doesn't work. On Linux, doesn't work. You have to, like your input, it doesn't work. So you want to make it so that it's always just /. Okay. So that's why. So we want to do this to the file path. Okay. And also, since just let's make some clean up so that in case if I give backslash, it will clean it up. Okay, so let's say xter equals to what I don't want to name, so this way just make sure it's always slash. So this change it xter to input okay. Change it to x input okay. So now run it. Okay, so we got talk show slash, correct. Now we want to skip the I directory, so let's try it to see if this skip mechanism works. Okay, run it. Okay, you don't see the slash I anymore. Fantastic, so it's working. Fantastic. Great, so we finished the Golang part. Now put it back. Syntax correct, showing browser. We finished the Golang. We haven't tested. We need to go through the script and to see if it exists actually. So but we can change that. Okay, then we need to measure the speed. Okay, so you can see what we need to do is described here and also here. So the last part is to go through the hash table. So go to the bottom, hash table for each key. We don't care about the value. We want to check if it exists. It's kind of redundant, but we are doing it for the sake of testing speed. So Golang map, how do you check an item exists? Okay, set value, delete key. Where is it? Syntax for map type, create map, literal expression, create map with make, get value. When a key does not exist, the first value is the map's type 0 value. Okay. So that's just the syntax. Okay, so basically we just so key x table, that key, if that equals to 1, then good. Okay, then good. Just print key, don't print the value. Okay. Else do nothing. Okay, so prettify the code. Fantastic. Okay, if the key's value equals to 1, do that. It's okay, so it's always exists. Good. Okay, that's fantastic. Now how do you check, how do you test the speed? We can, God, it's already 40 minutes. Okay, let's keep going. So to check the speed, we just do that. Okay, so split the window, go back to our code. So there, start time, and I already have the code here, so let's just use it here. Okay. So start time is there, and then at the bottom you say end time equals time dot now, and time difference is end time dot subtract start time in seconds, then time spent. Okay, so run it, run. Okay, so you undefined time. Oh, you need to load time. So one of the issues. Okay, fantastic. Time spent 0.3 seconds. Fantastic. Okay, so put it back, syntax color. That's it for Golang. Now let's do Emacs Lisp. Oh God. Increase the volume on my mic. You know, I think because of there's a upgrade of the OBS software I'm using, and it seems the volume decreased a little bit, but it's already at maximum. And also my microphone, I already turned it to maximum, and also actually it's very close to my mouse. So I think, you know, maybe you try to check. You know, I think I'm already at maximum, but I can make it louder, but that's gonna, you know, that's like doing advanced stuff. I like the light in the background. Okay, so anyway, so we finished Golang. Now let's do the whole xahlee info. Let's see how long it takes. It shouldn't print. I don't want it to print. 3.5 seconds. Wow, so it's actually very fast. So where is it printing all that? Oh, because of the hash table. Yeah, I don't want it. So if we don't do that, can we do that? Yep. Oh, it's even faster if you don't print it. Okay. So anyway, that's the Golang. Let's do Emacs Lisp. Okay. God, Emacs Lisp is, you know, I've been doing Emacs a lot, so why don't we try Wolfram language? That would be interesting. Okay. Because Emacs, I've done like tens of videos about creating a hash table. So let's do Wolfram language. Okay. So so what we want to do is this. Okay. What? Oh, Wolfram language. Okay, so actually create a hash table. Each key is that. Then okay, so hash table. So what is the directory? This let's try that. Okay, so directory, and also another important thing is this the to skip. And okay, so how do you, okay, so I don't remember. So let's see, Wolfram language tutorial. How do you so first of all, you want to walk directory. Okay, so walking a directory is gonna be data structure directory. So that would be God, I need to walk read file, load file, shell task. Okay, file path functions, walk directory there. So it's very simple. Okay, just file names. Return a list of all files and directories in the current directory. Okay, that's so extremely simple. Okay, file names. Yeah. Okay, so input the. Okay, so this is input directory. Then you just say file names. File list equals to file names input directory, but we want to filter some of them out. Okay, so let's see, string pattern, we want every file except any of the patterns. So that would be interesting. So there are several ways to do it. One way is simply just do this. Okay, so simply do this, and it should create a list of files. So let's see. Yeah, so let's just run it. Starting Wolfram language, it'll take a while for the first time. Okay, so it says done. So why doesn't it print? Okay, yeah, because you put a semicolon. So now run again. It's just one file. So input directory, file names input directory. So why is it just one single file? File name string pattern, list files of current whose name. Okay, yeah, oh yeah. So you need the string pattern and okay, so all you need to do is actually say all here. Okay, wait, wrong, lowercase there. Oh, there. Okay, so now you got like all the names. Copy the buffer, new buffer, paste it. Now make it one line each, so you can see it includes all files. Now you got this wonky backslash and slash. Okay, so for example, that's a thumbnail to my YouTube. So but that's how you do it. So it's done. 1,000 files, 1,500 files. So you get the close that. Now you can change this all to a pattern, to the files you want to skip pattern. Okay, so so you want to some kind of like skip those. So you need to let's see the documentation again. File name string pattern. So you want a string pattern that, okay, you want a negation of a string pattern. We can do that. Okay, so let's do that. So for example, if you want to do by extension, that's all you have to do, but we want string pattern, so let's do that. String pattern can be regular expression too, I think. The pattern can be wildcard pattern or regular expression. Okay, okay, let's try regular expression. So copy okay, so let's go to talk show, today's talk show, and go to the top, Wolfram language, traverse a directory. Okay, so okay, so what we're gonna do, what we doing is that this is check local links, close. So Wolfram language, we are getting a list of file names. Yeah, we want to do a string pattern and list files association. So how do you do string pattern? Regular expression. So you can use string expression. So let's use string expression to be different. So Wolfram language supports regular expression, like the normal regular expression, but it also supports its own, basically its own syntax for regular expression. So let's do this because this is would be interesting. It would be novel. So you want a string expression, okay, and okay, so that's what you want. Okay, so here you want string expression. Okay, and what expression you want? You want some kind of not. Wait. Okay, so you got the pattern syntax here. And so what we want is we want an expression that says not any one of these. Okay, not any one of these. So that would be interesting. So what? So let's just try a simple one. Let's just say we don't want the I directory. So okay, let's try that string expression except maybe a walk. Let's first of all, let's try that. Okay, so then okay, so what the fuck? What? Okay, so you got the I directory and wait, what are the other I directory? Oh, so it didn't dive into the I directory. So okay, so it did not dive into. So you want to include subdirectories. So Wolfram list files. Okay, so you want to dive into subdirectories. So that's what you want. Oh yeah, you need to specify a level. Okay, so that's very interesting. So instead of that, here is the depth. So you can say 2 or 3, or you can say infinity. Okay, yeah. Now run it. Okay, now make it each line, one item per line. So you can see all these files in the I directory. So there's a lot of JPEG files, for example, SARS-CoV. Okay, so but now we want to skip the I. Okay, so which is instead of all, we use that instead. Okay, let's try. Run it. Empty. Okay, so this expression is not correct. Except that so oh god, this is gonna take a long time. This is not because it's using backslash. Oh god. So try this, try that. Okay, empty. So this, why is that empty? So backslash oh, so it only checked the file name, it doesn't check the is that right? So this, the first argument here can be a pattern, but that pattern only match the file name. These files of kernel whose name match a string pattern. The pattern can be a wildcard or regular expression, right? So the pattern is not checking against the full file path. In other words, it doesn't check the directory part. That's why this doesn't work, because it's not seeing the directory. So okay, that's that's fine. Let's just do filter. Okay, now you got a list of files. Now you just want to filter. Okay, so how do you filter? You can use cases and others. So let's have a look. Wolfram language. Okay, at this rate we're not gonna finish it, but let's try. So you got a list of things, you want to filter them out. So so that would be list under list. Okay, so list, you got list position, list level, list operations. Then you got filter. Okay, so you can filter by a function, or you can filter by a pattern. Filter list by pattern. Let's see. This is symbolic pattern. Okay, so yeah, in our case, our list, every item is a string. So can this actually use a string pattern? I'm not sure. Literal expression, filter element by pattern. So let's look up the documentation for cases. So is this interesting? So ACP's question, why did you add a path to a map? Because map is what we want. Because we need to check if because many reasons. So first of all, in Golang, there's no function to check if a file exists. There's basically none. You have to write your own, but even if you write your own, you rely on the error message. You check the error. If the error is true, then you know the file doesn't exist. So that's kind of, I don't know why is that. So you can create a hash map for a list of files and just check the key exists. That way is, a workaround to check if a file exists without, checking the error, trying to access the file and get the error and check the error. So that way might be faster too. So that's one of the reason you create a hash table of files in all directories instead of just a list. Okay. The other reason we want a hash table is because we are writing a program. Ultimately, I'm writing a program to check all file links in 10,000 HTML files. Each HTML file has 10 or 30 links. Each link is a file path, pointing to another file. So you are essentially checking file existence 10,000, 100,000 times. So when you have a hash table, it's very fast to check if the file path is already there. So you don't have to check file existence. Okay, that is the reason we are building hash table. So anyway, back to Wolfram language. So we want to know if we got a list of strings. We want to filter the list. So there are many ways. So one way is just filter by a function. This is familiar to most people in Python, in JavaScript, in every language. You create, you can filter by a function. Okay, that's boring. So I'm trying to see if we can use this pattern matching in Wolfram language, just to demonstrate something different. That's why I'm looking into, this. But the question now is, can this pattern be a textual pattern? I don't think so. Okay. Yeah, that pattern is symbolic pattern, which means basically your syntax, basically your expression. So let's not use that. Okay, so let's just say select Okay, select select then file list. Okay, so wait, so let's rename it because when you have something non-English, it's easier to complete and so on. Okay, now you need a function. You need a function, and this function will be will try to match the string. Okay, so you need a function. The function takes okay. So where is it? The function takes the argument. Then the expression is if that match. Okay, string match something, string match or match string. Okay, so we need to go back to Wolfram language to check for string function. We want to check match string match. Okay, string start, string ends, string match q. Okay, so that's that's an example of using regular expression. Okay, so string match function x. Okay, so that's x. So here's a regular expression. Regular expression, if it's I, let's say, then you want to negate it. Okay, so string match and not. Okay, basically, so new list something. Okay, let me just try it. Okay, so now you just need to print new. Let's try it. Okay, regular expression, something missing. God, what? Oh, so wait, string match q, string and pattern. Okay, regular expression pattern. Okay, so why is that missing? This backslash is always very annoying. Okay, run it. Okay, I don't want it. I don't want that. So let's say, so if it says at the end of code, then remove it. Okay, so just for testing purposes now. Okay, run it. So it's still got a end of a code. Did we filter? Wait. Are we printing the right thing? So this is what we want to print. So function select. Let's not string match. Function string match that regular expression at the end of code. What is this string pattern regular expression? Yeah. Empty. Okay, so is that because, yeah, okay, so that is why. So now you can see, now it's all just at the end of a code. Okay, so but what we want is we want I, okay, and we want to negate it. So if it contains I, remove it. Okay, now, but this regular expression, is it because you need 4 of it? Fucking annoying. That backs, What? what? Oh, wait, this not needs to be here. That's right. Okay, so now it's still I there, so so you actually need this is quite annoying. This is not the right way to do it, but we are okay. That's pretty bad. Okay, maybe that's enough of Wolfram language. Because I haven't, Wolfram language, I haven't been using Wolfram. I have not used Wolfram language to do this kind of text processing much. So now it's not smooth, and we are just like all screwed up. We are trying to, so let's get a file list, and we are trying to, it should be very simple, okay? So, and we were trying to use string expression, then we switched to regular expression, and this should be string contains, okay? Not string match, because I'm not paying attention, I'm not concentrating. Okay, not strand, string contain, there it is, not string match. Okay, so if string contains, in this case string contains x, and we don't even need regular expression anymore. So if we just say string contains, then maybe that can we do that? Successful. You see, it doesn't have, if I go to the talk show directory, not here, we delete the, if I go to the talk show directory, talk show, you see there's a image directory, and there's got 500 files there, and now they are not shown because of this. So we successfully filtered them out. But right now it's just one of these. We want to filter them out for all of that. So in order to do that, you can just map. Okay, so do I need to? Okay, I'm just okay. The to skipped equals to, then this make it into a list. Okay, you want a list of directory to skip. Okay, and so each one is a directory. Okay, then we gonna slot, so then the new list will equals to, you want to map this to this. Okay, so basically new list equals to map. Okay, you want to map function to, you want to map a function to file list. Okay, then here is the function, and what this function do is that this function will basically will recurse. Okay, so wait, so for each one of these you want to go through reduce fold. Okay, so actually you need to use fold, functional programming, fold the to skip. Okay, now you need apply a function to it, and then you need the first item. Init value. Okay, let's look up the documentation. Fold fx list. Okay, so initial value, that's just so anyway, what you're gonna do, so for each one you want to select, this is getting complicated, select from file list by this function. Actually you don't, you can just pass it multiple criterions in select. What? Oh God, I need to code Wolfram language more, because right now it's not it's not going so well. Okay, so like one idea after another. So I guess should I stop? There's 7 people watching. Is it interesting, or should I switch to Emac Lisp? But Emac Lisp, I've been doing it so much. So actually the trick is you really just need to think about it. You cannot just like trial and error and doing pot shots. So let me relax and then take it slowly. Am I doing fine? Yes. Star Wars. Okay, so let's get back to what we need to do. So we got a directory. We got an input directory. We got an input directory. We want to go through every file in a directory, but skip these directories if the name match. Okay, and one way, so this should be over here. So above that is all parameters, kind of good coding practice. So input directory and directory to skip, that's a specification. Then you start your code here. So this file names gets all files in a directory to the depth of infinity. Okay, then now it can also take from nth level to mth level, and it can also take multiple directories. So yeah, so it can okay, and you can also even specifically specify nth level of a directory. So if a directory is nested 3 levels deep, only that files in those directories. So you can do that. Okay, so this gives you a list of file names. What pattern? All of it doesn't. So do I care? Actually, so the pattern only matches file name, not directory name. So this is useless for me. Better double check. Yeah, so So the thing is, we are trying to figure out how to do this. Wolfram language is normally used for mathematics, physics, engineering, but this traversing directory is usually sysadmin text processing. So so I haven't used this much. And you can also give it several directories. So but we want to skip some of these. Okay, so one of the so one of the thing we can think about is there some built-in function that just do it one shot, like we don't have to do map or filter or select. That's a so we want to skip these directories. So if one of the parent directories contains is one of these, we want to skip it. Okay, suppose there's no such direct function. Okay, then what we do is we can do a filter. We get everything first, but that's not efficient, because for example, if you have Git directory, usually there's like hundreds of files in it and lots of subdirectories. So you don't want get all names first, then filter out the Git, whatever contains the Git path. Oh, that's an issue. Okay, that is a issue. So now there's a question. So if we are doing this for real life problem using Wolfram language, how do you solve this? We can get all files first, then filter it, but that's not efficient when you have like Git. So another way is you can it must this must be a way. So we have to just carefully read the documentation. Okay, there's no way around it. So file names form list of files in the current working directory whose name match the string pattern form. But the problem is it only match the file name part, not the directory. If it matches directory, then we are solved. Okay, so let's read in detail. File names can be given as literal strings or string expression or regular expression. Okay, in abbreviated string patterns, star stand for any sequence of 0. So that's wildcard pattern. Okay. So let's see next. So verbatim specify the string should be matched with wildcards. Okay, so that is like verbatim, wildcard. Then you can say infinity for so-called recursive, in idiotic jargon in Unix, recursive. In fact, it doesn't mean recursive at all, because recursive means implementation. It does not mean, it just lists, it does not specify subdirectory and all its subdirectories. For example, let me say it this way, it's simpler. So for example, if you have a tree, you don't say, if you want all the leaves of a tree, you don't say recursively get the leaves recursively. That's not what you say. You simply say all the leaves or all the branches of a tree. You don't say all branches recursively, because recursive is mostly a verb that's related to implementation. So if you want to get all the leaves of a tree, you can implement your program in a recursive way by writing a recursive function that calls itself. Or you can use nested loop. So when you say get all things in a directory and subdirectory and all their subdirectory, it is, the word recursive is irrelevant. But the Unix and C idiots, they don't know. So for example, in Wolfram language, they don't say, when you have infinity, the third argument specify how deep you want to go. So you can say infinity, which is represented by a symbol. It just means all levels. And then, it explains that it looks for files in all subdirectories of the. It doesn't say recursively, like the Unix idiots. Unix and Linux, and basically that, bad concept, bad thinking spread to all programming languages, industrial coders. They always just say recursively. Anyway, that's a digression. Okay, so we are reading this. So file name, so list of files returned by file names is sorted. Okay, that's kind of make it slow. Then file name form, then you can add a braces to the third argument so that it only includes that level of depth. Okay, the forms can include relative or absolute. Oh, wait, here. The forms can include relative or absolute directory specifications there. Okay, so that is the key. So we can specify our patterns here. Okay. Yeah. Yes or no? Yes. Okay. The question is how, but that's a detail. We'll see. Okay, setting the option ignore case true. Okay, that's ignore case. Okay. Then fantastic. Okay, so the form can include absolute directory specification. Now we need an example. Okay, Jesus, they don't have an example. You see, in this case, there's only one example because this is not typically, mathematics or physics, so not many people is using this. Okay, so but you see, this sentence is most important. The form can include relative or absolute directory specification. Okay, but how match the form? So this needs to be a pattern, but how do you specify? You need a negation pattern. Okay, so if we let's try this again. Let's forget about that. Okay, so this part can be let's say what? Oh, we need to do that. Okay, so now it's just all event of code because it only matched that. You see. You see, because we searched for event. Okay, but we want a negation of these. Okay, so let's try. First of all, let's try to see how to get negation work. Okay, so file name is a pattern. So instead of using wildcard, we now use string expression. Okay, and in this case, string expression, let's just say event. Okay, Now let's do that. Let's see. Run it. None. Okay. Now, okay, maybe let's not try that yet. So let's just try that. Okay. Run it. Empty. Wait, so this form, can they be string expression? Yes, they can. Says right here. File names can be given as literal strings, string expression, string patterns, regular expression object. Okay. So, oh yeah, but you need to, the problem is you need to match all part of it. Not just event, because the event won't match. You need to match all part of it. So let's go back. So let's get these to work. Okay, I'm just pressing on. So you get back to about string expression. Okay, so a string expression, any single character class. Okay, so so character class, letter character, any single character. Okay, so character class exclusion. Okay, match boundary. Okay, we don't care. And repeat. Okay, so repeat, you just say ... one or more times. Okay, so let's say let me show you how this works. Okay, so string expression. Okay, so letter character ... so that means one or more letters. Okay, then something advanced, but actually we want to include the slash or backslash. Okay, but let's say that. Okay, so now if we run it, that won't work because we don't have any slash character. Okay, what about any character? So underscore is any character, so let's just say underscore any character one or more times, then event, then any character one or more times. Do it. Oh yeah, we're missing a comma. Yeah, comma. Do it. Invalid syntax. Wait, any character. So underscore means any single character. Okay, so why is that? Pattern one or more times, zero or more times. alternatives. Jesus. It's starting to get annoying. This when I don't think so. Okay. Oh, right. You need parent. Jesus. Okay, so now, fantastic. You see. So what we done is that we are using file names, one single function call. Okay. Now let's brag about this. You see, we want all files in this directory, but skip this, and now we only one single function call give us the result. Okay, let's remove that. Okay, one single function call, and this function is just file names and takes 3 arguments. Okay, a pattern of the file path, full path, then the input directory, then depth. Okay, now the pattern is the tricky new thing here. The pattern, we can use a regular expression. We can, I can try a regular expression, or we can use string expression, which is a new kind of syntax, similar, almost similar, very very similar, same purpose as regular expression. Okay, and here we say, the string expression can take any number of arguments. They basically just join them. Okay, remember this represent a string pattern like a regular expression. Okay, so the first thing you say is that any character one or more times, then followed by advent, then followed by any character one or more times. Okay, so one single function call, you get a list of all file path, full name, and skip and only match this pattern. Okay, so what we want to do now is we want to negate it. We want to check if it does not match any of these. Okay, and so negation is here. So literal character sequence, any single character, you just have to read it carefully and think. You cannot rush. So is anyone still here? So okay, any single character classes. Okay. Character classes, then character class exclusion. So you got except. Okay, so except allows you to we want to try to have a except. So except this. So except a pattern. Okay, so actually we can do this. Let's see, except the pattern. Okay, so copy that, make a copy, then except it, instead of advent we say except advent. Okay, now comment that out. Wait. Run it. No. Except or. Okay, so maybe except. Why is it except doesn't work? I don't understand. Run it. No. Okay, I think maybe I should stop. Zero or more times. Okay, let's try instead of one or more times. Let's say wait. So I don't think this works. This is embarrassing. Alternatives. Named capture. Okay. Conditional check on pattern. That's it. So what we want is anything, one or more. Okay, probably everyone is gone. God. This. God. So, partner. God. Need to get this to work. So, we are trying to match your pattern, and this is the text pattern. One or more. But except, how do you express except a sequence of characters? Okay, you just have to think carefully. So you got string expression pattern syntax. Okay, so here is a sample code, literal character sequence. Okay, except a pattern that is not pattern, a pattern that is not pattern. So this pattern, why can't this work? Except event. The argument to accept can be a string, right? You know, here's an example showing the argument is a single character string. Okay? But it could be more than one character too, right? Now, do we have a link to documentation? No. Shit, I need to add it. No, I don't have link to documentation, so what? Oh, that is because, this is incomplete. Shit. My tutorial here is incomplete. That is why. So let's go to string expression and let's go to Wolfram language. Okay, yeah, so Wolfram language has got the full thing except that you guys cannot see. Okay, so let's go to example and ignore case. Let's go to Wolfram language documentation for the string expression. Okay, so this is spectacular and very complicated. So you can see, so what we need to do is that we want we have a list of strings. We don't want to match any of it. Okay, so you got pattern, any order, fixed order, pattern condition, number in string, and you can also include regular expression. You can embed regular expression in it. Oh yeah, you got characters and character range, hexadecimal character. So, but except, so any character except once. Okay, so except is, okay, so shortest and longest. Okay, so but date pattern, number string, white space. Okay, I haven't found. So here is patterns. Here at least match one of these patterns. Okay, but how do you negate it? You see, right now, this pattern, how do you say, you can, so you can construct a syntax using all these elements to represent a text pattern, okay? But once you have a pattern, how do you say, anything that does not match this pattern? In other words, negation. So that is tricky even in regular expression, because in regular expression you cannot negate it. You can only, you cannot negate the pattern except in a class of characters. But you cannot negate, you cannot say whatever does not match this pattern. You can sometimes do that via the function that uses a regular expression. So the function can say, grab print only if it does not match, this pattern. So the function that uses the regular expression as argument, the function may be able to say, return only if it doesn't match. Okay, but the regular expression itself, does it have a way to say, negate the whole pattern? No, I don't think so. Okay. So, but what about Wolfram language string expression? So Wolfram language string expression is like an alternative to regular expression. So regular expression does not have a way to negate a pattern. Because I think because by the very semantic of regular expression is supposed to match. It's not supposed to express something does not match. But it should be possible to negate, but it just, I think historically it just never happened. So anyway, in string expression of Wolfram language, does it allow you to negate a whole pattern? Okay, so that is the question. So that for that question, we have to read the documentation carefully. Any order, fixed order, pattern and condition. Pattern for which condition evaluate to true. That is like extra test. Character object, an object representing a character class. Okay, so string expression, arbitrary string expression. So you can embed string expression inside string expression. By the way, Wolfram language, the implementation of string expression is that it converted to regular expression. So it's kind of funny. So anyway, characters. So that's any, you can specify a character class by this, and character range by this, and hexadecimal characters, digital characters, letter characters, white space characters, word. So what about the except? That looks really promising. That should be that. Really, this should be is a pattern object which represents any expression except one that matches. So this is what we want, really. Okay, but how do you see? But you see. Oh, okay. So let's use it outside. Okay, so let's let's try this. Okay. Wait, except takes. Okay, so this is a bit complicated, but let me show you. Okay, so we have nested string expressions, I think. Okay, string expression, then inside it, it's a except. Then inside except is a string expression, and here is just advent. Okay, so that is what we're gonna try. Very advanced. Okay, so we got like, now we have nested string expression. Okay, please make it work. Warning, comma. Okay, oh yeah, we got extra comma. We don't want. Okay, now do it again. None, which is incorrect. Okay, this idea failed. Wait. But now you don't need this. Maybe we are making it far more complicated than necessary. No. You see, the thing is that you really do need to match the whole. Okay, so no. God. What? Okay, so wait, let me try another idea. So this except not working. What about alternative? Okay, so we can use alternative, can we? Yes. Okay, so that no, we really want negation. We really want negation, but we don't know how it works. What Emacs theme do you use? Just search for Xahlee Emacs theme. You will find it. Okay, I think maybe that's it. This is not working out. So the real question is except, but it seems to, but did we look at all the examples? Except works in string expression. Okay, this is what we want. It's a pattern object which represents any expression except one that matches C. Okay, that's what we want. But but there is no good example. You see, there's no good example. We want right, over here it's using it as a, that's basically a character class. That's not what we want. We want a character sequence. And here it's using it as a symbolic pattern for integers, not string match. And here it's using, okay, here is a string, but it's except digit characters. So digit character is a sequence of characters. Okay. Right. What we want is a, negation of a sequence of characters, not this. So here's another example. This is symbolic, integer. Now use a text pattern matching. That doesn't work. I mean, except oh wait, my mouse is out of battery. My trackball, fuck. Okay, applications. Applications. No, okay, so you see, it's not, it's not right. So I think actually we stop today. We stop now. Okay, needs more work. Okay, bye guys.